Hi guys, today we're going to continue our discussion of 3D shapes, and we are going to actually look at them in a two-dimensional form first. So this is called a net, and it's just the picture of the shape on a piece of paper, and that can be folded up. And so what I thought we would do today is I would give you the net, we'll look at it, and we'll talk through what it would be. Some of them are pretty obvious and probably what you're used to. Some of them may not be. And then tomorrow you'll have a matching activity with it. Okay, so I plan on doing a slideshow with these nets that we go through in the same order so that you can go back and review them. Okay, so let's see how this goes. Okay, so let's start off with this one. Okay, remember on a net, the dashed lines are just for folding, and so those little triangles there are just to help us fold better. So what we are focused on here is we have a rectangle and two circles. Okay, so what shape that we've talked about would be made up of a rectangle if you were to fold that and two circles. Okay, and yes, the correct answer would be a cylinder. And so, this isn't the best, but forgive my tape. But we do have a cylinder. Notice the two circles are your bases, and then this was just that rectangle wrapped around. So I think a soup can is a great way to think about a net for a cylinder, because if you take the label off of a soup can, it is rectangular. You use a can opener, right, and it cuts a circle on the top, and you could do that on the bottom as well. So the net for a cylinder is always a rectangle and two circles. Okay, so what about this next one? Okay, so what do you think this is? So if we look here, it looks like we have 6 squares. And so what do we know that is made up of 6 squares? Okay, that would be a cube, right? Or your standard dice. This is not the only net of a cube. I think it said there were 11 different ways that you could draw a net for a cube, but they would all have to have 6 squares in them because that is what a cube is made up of. Okay, so do you remember what the name is also of a cube if you consider it to be a platonic solid? Okay, it's a hexahedron. That's the other name for it. Okay, so the net for a cube is always 6 squares. Now it's not a mixture of any 6 squares. Okay, there are some that you could cut out and never be able to fold into a cube. Okay, so what about this one? What do you notice here? So here we have 2 triangles, okay, and then we also have 3 rectangles. So if we go through our shapes and think a minute, can this be a cylinder? No. Can it be a cone? No, because those all need circles. Okay, so then what we're left with would be a prism or a pyramid. Okay, so if we think about what a prism and a pyramid have, prisms have to have 2 bases with quadrilateral sides. Okay, pyramids have to have 1 base with triangular sides. So here we have rectangles and triangles. So it could be both possibly, but we need to look at what we have closer. Okay, so here I have 2 triangles, and those could be the bases. Do we have enough rectangles to make up the sides? Okay, well, I would have to have a rectangle for each side of the base. So here, yes, I have 2 triangles and 3 rectangles. So this could be a triangular prism. Okay, now could it be a pyramid? Well, to be a pyramid, all the sides have to be triangles. So that would mean our base would have to be a rectangle. Well, we have too many rectangles for that. Okay, so this does have to be a triangular prism because this would be our bases and then these would be our sides if we were to fold it up. Okay, so an example of that is this right here. Okay, so notice my triangles are right there. If I were to unfold those triangles, they would match. And then here's a rectangle that would fold down here, the rectangle on the bottom, and then I have the rectangle that would fold here. Okay, so this is a triangular prism when I have this. Okay. here I have all triangles. Okay, so what could this be? Can it be a prism? Okay. And the answer is no, because we have no quadrilaterals. Okay, and it can't be a cone because we don't have a circle, and it can't be a cylinder. And so what we're left with is either a special platonic solid, okay, or a pyramid. So a pyramid has to have triangular sides, and it has to have one base. Okay, so this would be a pyramid because we could have one base, and then we have a triangle for each side. So this would be a triangular pyramid. Okay, that would be this one right here. So notice I can peel this down, right? And that would be a triangle. And I could peel this down, and that would be a triangle. And I could peel this down, and it would be a triangle. So this is a triangular pyramid, okay? Because I have a base that's a triangle, and all sides are triangles. This is also a platonic solid. Do you remember its special name? It's a tetrahedron, okay? So this is a tetrahedron or a triangular pyramid. Okay, so what about this one? So again, kind of think to yourself, is this a prism or a pyramid? Cylinder and cone are out because we don't have circles. So what I notice here is I have a pentagon, and then I have lots of triangles. And so how many triangles do I have? It looks like I have 5. And so does this match a pyramid or a prism? Okay, well, pyramids are the ones that have the one base. So this is the oddball, right? The base, and then it has to have triangles for its sides. Okay, so to be a prism, we would have to have 2 pentagons, and we'd have to have rectangular sides or quadrilateral sides. So this is a pentagonal pyramid. Make sure I have the right one here. And so if we notice here, okay, it would be like this. And so there's the pentagon. And then if I were able to peel this like a banana, I would have 5 triangles that would match here. Okay, so that is our pentagonal pyramid. This is not the only way that a pentagonal pyramid could be drawn. Okay, we could have, I will make note of that. Okay. We could have a pentagon like that, and then triangles right here. Okay. And that would also be a pentagonal pyramid. So when they have stars, it looks like a star. That would be a pyramid. Okay. So pyramids could be drawn differently. So that being said, what do you think this is? Well, I see triangles. I see 6 of them, and I see 1 oddball, which is a hexagon. So again, triangular sides go with pyramids. So this would be a hexagonal pyramid. So I have a hexagon that's on the bottom, and then I have triangles on the side. Okay? So this is one way to draw the net. Just like our previous picture, we could have this as a net as well. Okay? So again, you would have a hexagon, and then you would have a triangle at each point. So this is a hexagonal pyramid. Okay, so what about this one? So cone and cylinder are out. Is this a prism? No, because we have no quadrilaterals, right? Prisms have to have quadrilaterals for the sides. Is this a pyramid? No, because you have to have triangles for sides. So what do we have left? Well, that's the platonic solids, or those special polyhedrons, okay? So that we only had one of those that had 12 faces, and that's what we have here, right? There's 6 here and 6 here. And so there are 12 faces, and they were all pentagons. And do you remember that special name? Okay. It was a dodecahedron. Okay. And so this is your dodecahedron folded up. Okay. So this, if I cut it out, I do get to make this. So a net, again, is that 2D shape that you can cut up and fold to make a 3D shape. Okay. So what would be made up of almost a triangle and a circle? Okay, well, this would be your cone, right? You have a circular base with the triangle that wraps around the circle, okay, and it's a rounded triangle. And so you have your cone here. Okay, Okay, so what do we have here? Okay, well, it looks like we have 2 squares and 4 rectangles. And so you do have 2 separate shapes. I know this isn't a cone or a sphere. I also know it's not a pyramid because there's no triangles. Okay, this also cannot be a platonic solid because platonic solids have to have all congruent shapes. Okay, so this leaves a prism. And so what kind of prism do we have? Well, that's where we go look for the 2 identical shapes. Okay, so I only have 2 squares. So this must be a square prism. Okay, it could be a rectangular prism as well because we can call squares rectangles, but it does just fold into your box. Okay, and so again, I can peel the sides here and that would match, and then this would come down. Okay, and then these would fold down and hit the rest. Okay, so this is a rectangular prism. It's made up of squares and rectangles. Okay, so what about this one? Okay, can this be a square or a cylinder? No. A cone? No. We've already seen those. Can it be a prism? No, because we don't have quadrilaterals. Okay. Can it be a pyramid? Possibly. But to be a pyramid, we'd have to have a triangle because that's all we have here. And then you would only have 3 other sides, okay, to fold up. And we've already seen that triangular pyramid. So that leaves this to be a platonic solid, which does match because I do have all congruent sides. And so our faces, this is the one that has 20 congruent triangular faces. So its name is an icosahedron. And my icosahedron is right there. Okay. And so this does fold up into a shape like this, which does hopefully look like that website you looked at yesterday. Okay, so what about this one? Well, what I notice is I have some quadrilaterals, and it looks like there are 8 of them. And then I have 2 oddballs that are the same size, and those are both octagons. So if we think about the properties, this has to be narrowed down to a prism because I have 2 shapes that are identical, and then I have quadrilateral sides. Okay, and so we do name our prisms by their base. And again, these 2 have to be their bases, the top and the bottom, or the left and the right. Okay, and this would make it an octagonal, okay, or octagon prism. And that matches with this right here. Okay, and so if you'll notice, that's what it folded up to. So I have my top and my bottom, and then each of the sides are those squares. Okay. How about this one? What do we have? Okay, we have 1 base, and then we have triangular sides. So that means it should be a pyramid. And what kind of pyramid is it? Well, it all depends on what our base is. And in this case, we have a square. You could say rectangle as well. But we have a square, so this is a square pyramid. Okay. So again, we have the square on the bottom, and then we have the triangular sides. Okay, so just a few more. So this one, what do you think? Okay, well, this is your hexagonal prism because we do have 2 bases with the rectangular, or in this case, square sides. And so it does fold up to make a hexagonal prism. So here's your top and your bottom, and then all the sides are squares in this case. They could be rectangles. Okay. 3 more to go. So what about this one? So here I noticed 2 oddballs, right? They should fold across from each other, top and bottom. And then I have rectangular sides or quadrilateral sides. So that should lead us to a prism because prisms have 2 bases with rectangular sides or quadrilateral sides. And so we now look at our bases a little more closely, and this is a pentagon. So this would be a pentagonal prism, okay? And so it could be like that, or it could be set on its side. Okay, however you want to look at that. But I do have the 2 bases with the quadrilateral sides. Okay. So pentagonal prism. I think of this one a lot as a house. Okay, I mean, it's just a very basic house you might draw. Okay, and then this one is probably the strangest one. Okay. I notice I have two trapezoids, okay, and then I have quadrilaterals, and they're not equal quadrilaterals, but I do have quadrilaterals for the other pieces. So I know this is not a pyramid because I have to have triangles, or a cone, or a cylinder, right? So this does have to be a prism. We look for the two shapes that are identical, okay? And yes, we have two rectangles that are the same, but the trapezoid is the strange one, or the two bases. Okay, so we have the two bases here with the quadrilateral sides, so it does fold up into a trapezoidal prism. Okay, which if you think about it, those Quonset huts and things like that are the trapezoidal prisms. Okay, so that is what would fold up to make a trapezoidal prism. And then the last net I'd like us to look at is this. Okay, so immediately I notice that all shapes are congruent. This could not be a pyramid because I have too many triangles. It can't be a prism because I have no quadrilaterals, and it can't be a cone or a cylinder. So it must be one of those platonic solids. And it does have 8 faces, and that is our octahedron. Okay, so, and if we were to unfold this, you can see that everything is a triangle. Okay, and so if we cut this out, this is what we end up with. Okay, so hopefully that gives you some ideas about nets, how to decide what they are. You look for, do you have triangles? If so, it could be a pyramid. You look for two bases and quadrilaterals. Well, that would make it a prism. Okay, one circle with a triangular shape would be a cone. Two circles with a rectangle would be a cylinder. If you have all congruent shapes, then it would be some kind of platonic solid. So let me know if you have any questions. I will put these nets on a Google slideshow just so that you can see them a little more closely. So please let me know if you have any questions, and I will talk with you later.